that's what you would put in your formula as your multiplier. And so that's just, if you minus that, that's going to be 93%, which is going to be 0.93. So if you were writing an exponential equation, you'd have your, initial here, and in that parentheses here, you would have that 0.93. But we're not going that far on these first two. We're just getting the multiplier. Okay? A population of bacteria has an initial population of 1,200 and grows by 13%. What's the multiplier for the population? So this would be that 100% plus 13%, which is going to be 113%, and as a decimal, that is 1.13. Okay? That was also very easy, kind of just getting us to the formula question. Write an equation to model the population of bacteria. Use your equation to determine the population of bacteria after 5 hours. Please round to the nearest whole number. Okay, we're not going to have a partial bacteria. So y equals initial. So you got to go back and track and find that. Okay, we've found our multiplier. And there is the equation. That will tell us how many bacteria we have at any given hour. And this particular problem says, let's do that after 5 hours. So this would be TI active, calculator active. So let's get out of there. 1,200, parentheses, 1.13, right? 13%, 1.13, and up arrow 5. Okay, so round to the nearest bacteria would be 2,211. And we're always going to use our noun. Answer the question with the unit, if you will, and this unit is bacteria. Okay, now we're going to go into some money. You save $3,000 at an annual interest. You invest $3,000 at an annual interest rate of 7%. Determine the amount in the account run to the nearest dollar after 10 years if the interest is compounded quarterly and continuously. Useful formulas down here. Okay, so this is just your exponential, kind of in general. If you have a rate, then this b becomes 1 minus or plus the r for growth, and 1 minus the r for decay. Okay, but this is your continuous, your PERT, and this is for compounding. All right, so let's use this formula. Determine the amount. 10 years, that's time. Amount, this reads amount after 10 years. That's what it says, amount after 10 years. So we're going to, how much are we investing? Principal, 1. That means we're going to keep the principal. We're going to add on the rate. But if it's yearly, we just add on the rate. But if we are compounding quarterly, we're going to get a fourth of that rate quarterly. So we divide by 4. So quarterly is n equal to 4. This is your n. To the n times time, 10 years. And that is all you have to show in your work, and then you go to calculator. And the TI can handle a lot. Your scientific ones, I'm gonna kind of model as if this were a scientific. All right, so I would probably do 0.07 divided by 4, enter, plus 1, enter, caret up 40, enter, times 3,000. All right, and we are going to end up with 6,005, sorry. 6,000, can't see it. Set to round to nearest dollar, 6,005. So let's think about the reasonableness of this. 3,000, 10 years, 7%. That seems pretty reasonable. Compounded quarterly. So it's not out of the range of, you know, something that would be reasonable. So let's see, if you do a TI, you could do 3,001 plus 0.07 divided by quarterly raised to the parentheses 10 times 4. And you get the same answer. Okay, so there you go. Now continuously, you're going to switch formulas and use PERT. So 3,000 e to the rate, which was 0.07 times 10 years. So new formula. 3,000 times e, there's e, it's right above ln. On even the scientific, it's always, this is the natural logarithm, it's right above there. Okay, so times 0.07 times 10, close that parentheses. And this should be similar to 6,005, but better. And it certainly is. And that rounds to 6,041. All right, so that's 7.1. 7.2